Hello. In this talk, we want to tell you how to design and model complex systems in GeneXus. In a previous talk with Gabriel Simonet, we discussed 3 strategies for modeling and incorporating design systems in GeneXus. In this talk, we're going to focus on the third one, how to model systems based on design systems customized in GeneXus. These systems generally require high performance, such as being easily maintainable, scalable, being adaptable, and so on and so forth. All of this is what we call future-proof. For these complex designs, decisions start much earlier. They start with the people, with the design teams, with the designers. It is essential to have more and more good designers. If we make an analogy with code, the quality of a product often depends on the quality of developers. The same thing happens with design. The quality of the design of a product is closely tied to the quality of designers. What's more, quality often depends on the relationship between designers and developers. Having a counterpart on the development team who speaks design front end is necessary. But in addition to people, we need processes and tools. That's what we're going to talk about today. For that, we're going to explore this design. It is a design that we made for a travel agency, and as we can see, it is complex. It has a native Android application and an iOS application that is also available for tablets. They have a responsive website. It has a conversational interface, as we can see here, and it also has 2 themes, a light theme and a dark theme. We recommend that these complex designs be based on design systems. If you want to know more about design systems, you can visit the GeneXus webinars website, where we have several talks about design systems, or the GeneXus YouTube page, where there are also talks on the subject. To review this design, we're going to base ourselves on a methodology called atomic design, which has been around for a long time and has recently become popular with this name. It is what we could call component-based design. The idea of atomic design is to standardize basic elements and with that compose more complex elements. It is a foundation for design systems. If we go to the interface, we could refer to the most basic elements such as a button or a text field or a label as an atom. And with those atoms, we'll build molecules, basically group 2 or 3 of them, such as a text field, a button, and a label, and an icon to form a search engine. And by grouping these molecules, we can make up organisms, which are larger elements. But let's go to the layout to see how this is represented. Here we have Sketch, where we design the interface. As you can see, we have the same dark theme. We have the different pages that the designers have worked on. But then we're going to look for those elements where we were talking about. For example, here we can identify atoms such as this button or this icon here and this text. And we can start to group these atoms. We create molecules such as this element here to rank this trip. And by grouping molecules, atoms, etc., we generate this card. To modularize this design, we need subatomic elements, which are going to be called tokens. These are basic design decisions and are basic elements for the visual and interactive composition of our experience. And in addition to tokens, by composing those tokens, we generate styles. But let's see that in design. As we said, these are basic decisions. For example, the texts, as we can see on this screen, this text on the web and this text on the mobile application have the same typography. If we pay attention, other elements begin to appear, such as this button, which is the same that we use here in the mobile application. But it is also the same that we use here in the chatbot. And if we take a closer look, we begin to see other elements, such as colors. We see that here, this color is repeated. It is repeated here, and also here, and so on. And so with everything, for example, this button here has the same radius as this card, and this button has the same radius as the others, and so on. And some are even less noticeable, such as animation times, etc. Those are all design tokens. When we group these tokens, we generate styles. For example, as we can see here, these 2 buttons share the same text style, which we could call button label. For example, this button and this button share it. Although they are different, they share that style, and they also share certain properties on the background style. It is a flat background, it has no outlines, the same rounded edge, etc. So if you are a developer, you will ask yourself, okay, how do I realize all this? How do I conceptualize it? The good news is that if you're a designer, you're probably saying, but those are design decisions that I make all the time, and that's how I model it. And that's the case. If you look at this design, those decisions are already made in the design. Here we can see the color tokens, all the colors that this design uses in light mode and all the colors that it uses in dark mode are represented. If you take a look, you'll see that for the same color, for example, on surface, which is the color that goes on the surface, we have a white color here and a black color here. And the same is reversed for the surface when we change the theme. But there is more conceptualization about this design. If you go further, there are surface decisions such as these, and there are styles like the ones we talked about a moment ago. Here we can see the H1 style, for example, that makes up several tokens, the font it uses, the size, the color, etc. And here we have the negative option to use it in dark mode. We have the tokens, styles, atoms, molecules, and the organisms. But you may be wondering, how do we do this in GeneXus? Well, if we start from the top, the organisms, we have objects like stencils, which we've had for a couple of years, and allow us to define reusable and cross-platform interface elements. I can use it here, I can use it on the web, and I can use it in mobile native. For atoms and molecules, we have the GeneXus components, such as button, controls, and if we want to create our own controls, we have user controls that allow us to create complex controls. And at the subatomic level, we have to present you a new object called design system objects, which allow us to model tokens and styles, as we mentioned before. And we're working to be able to model what we call elements, which is a way to override native GeneXus controls. But at GeneXus, we always want to try to go the extra mile. We try to automate as much as we can. For that, we can import the GeneXus design generated from Sketch automatically. It is a tool called Import from Sketch, which we have renamed Import from External Design, because we're going to support very soon other design tools such as Figma, and it allows us to import design defined in Sketch to GeneXus with one click. We extended this tool to support the import of design on the design system object. How to continue from here? You can see Cecilia Fernandez's talk that will show you how to model a design on design system object from scratch, or you can watch Fabian's talk to learn how to import design from Sketch to GeneXus in one click. And you have the talk that I gave with Fabian where we showed a methodology to allow designers and developers to work together with this tool. We believe that we are in the best moment to import and model GeneXus design. There are many new tools to learn and get the most out of, so we look forward to your feedback and to seeing what you can do with all this. Many thanks.